All right. Welcome, everyone, to this week's DBA Fundamentals, Parallelism, and Microsoft SQL Server. This week, we have Torsten Strauß. Today is June 6, 2023. Hopefully, everyone is having a great day and a great time. In the upper right-hand corner of the screen, you see the three leaders of the DBA Fundamental Group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. We're actually the three leaders of the group, and if you have any reason to get hold of us or need to, that's funny. Why am I not sharing now? Maybe it's just me. You never know. Thanks for bringing that up there. All right. All right, so hopefully mine is sharing again. Please let me know. Oh, there we go. Thanks, Stephen. All right. So with that, beneath the three leaders of the DBA Fundamental Group, you actually see our various ways to get onto social media. First one being Meetup, where there are multiple past and present and future presentations on Meetup. That's the easiest way to find out when we're going to be meeting and how to get through all the different channels. Below that is our actual website, dbafund.org, where you can find all of our past presentations, all of the links to YouTube and whatnot for all of those, as well as our future presentations, where you'll see things like in the future, we'll be meeting with several different speakers, things like that. Also below that, I want to bring up the fact that we have dbafundtube.com, which is our direct link to YouTube, so you can find our channel there very quickly, and you can find all of our past presentations on there as well. When you're on there, be sure to like and subscribe to our channel so you can find out when presentations like today's are going to be out there for it. Below that, you'll actually see our Twitter handle, our Slack channel, and our LinkedIn group, where you can connect with us and talk as much as possible. As I said earlier, today's session is being recorded and usually available within 1 to 2 days. As always, it's on dbafundtube.com. Just a reminder, be sure to turn off your camera and please be sure to mute yourself so that we can focus on Torsten here as he shows off all of his goodness. We talk about parallelism. And as always, be sure to type any questions you have into the chat windows, where I'll be communicating with Torsten on your behalf, or Torsten can actually read them. All good either way. And with that, I now have the wonderful bio screen on Torsten, and I'm sure Torsten will be able to talk about himself much more than I could. So with that, Torsten, over to you. Torsten is on mute.
Okay, now I'm back. Can you hear me, Kevin?
I can hear you.
Yeah, okay, let's see whether the screen sharing works this time. You can see my screen, hopefully.
I cannot.
This is strange. I mean, I can see that I'm sharing. Still not?
Still nothing, sadly.
I have no idea. I mean, I'm sharing. Stop sharing. I only can give it another try and hope it works. This is so annoying. I mean, Teams is
It's Teams. It should just work.
Yeah, it is. That's true. But I wonder, is there a possibility to use the web link instead? I mean, this is crazy. I will leave another time, and once again, I have one idea. Just give me a second.
All good.
It looks like there might be another user sharing. I see something from Jesus Cabrera. Maybe if they could turn theirs off, this would get fixed.
So I don't see it. I see where he's trying to show like his camera where he's in video, but I don't see any actual sharing from Jesus.
Okay, so I will give it another try. So I switch back to the old Teams version. Maybe that works.
No, nothing.
One second. Now I'm presenting. Maybe that works.
Nothing yet.
I see someone's email. Nope, there's stuff there now.
Okay, that's great. Can you see the PowerPoint presentation now?
I can.
That's great.
Yes, as long as somebody sees it, they're doing good. Cause I don't see anything, but hey, if everybody else can see it, it's all good for me.
Oh, this is crazy. I mean, this is a very good start for me. Yeah, so you're getting nervous as a speaker when you cannot share your screen. So yeah, sorry for that. I hope it will work. I hope that the session, or at least Teams, is stable for the next roughly 60 minutes. So let me introduce myself. I mean, Kevin already introduced myself, but I can see that some of the people joined a little bit later. So my name is Torsten Strauß. I'm a speaker, consultant, and trainer from Germany. I'm an MVP, I have some certifications. That really doesn't matter. The most important one is my email address. So in case you have any questions with regards to performance tuning, you can reach out to me. I cannot promise to answer your questions, all of your questions, but I will give it a try. So let's see. So you can remember my email and you can contact me if you have any questions, especially with regards to the session. So what
Torsten, it looked like we've lost ability to hear you now.
I'm back. For whatever reason, Teams decided to quit. I need to share another time. So is it working now? Can you confirm that?
At least audio wise is fine. I don't see anything, but
Okay, I'm back another time. So this is super annoying. Let me try to share. It was working the entire day. So
works until it doesn't.
So can someone, at least you can hear me, which is good. Can you see my screen now, or is it still not working?
I hear you just fine. I don't see anything from your screen though. There we go.
Yeah? You can see my screen? Oh, that's great. I mean, sometimes, yeah, okay. Okay, let's start. Hopefully, Teams will not quit another time. I don't know what is happening, but I'm using the new Teams version. For whatever reason, it seems that the last update, which was, I don't know, which was delivered today, causes some issues. Anyway, so hopefully everything works now. So what I'm going to present is a topic which is not a very easy one, but it is about parallelism. So parallelism in SQL Server, to be precise. And when I talk about SQL, or when I name it SQL Server, I'm talking about Azure SQL Database, Azure Managed Instance, SQL VM, SQL in Azure SQL in RDS. So there are a lot of flavors with regards to Microsoft SQL Server. So everything you can see here is true for all the environments and all the different even cloud providers. Yeah. So, okay, so what I've done in the beginning is I created a few tables here just to have some bigger tables, because I'm using the AdventureWorks 2017 database, and in this database you don't have very big tables. That is the reason why I created some of them, which I will use over time. So I just want to give you an example. So this is
Apologies, everyone. As Torsten seems to be having several issues with audio. Hopefully he'll be back here in just a second. We can continue with no more issues. That's my hope anyway. I'm sure all of yours. We're waiting for Torsten to rejoin us here. That's the only reason why he's not speaking at the moment. Thankfully, I am still not near where Torsten is. Well, he said he was going to try to rejoin us. If we need to, we can reschedule this meeting. I am not concerned about that at all. If he doesn't, because he's not able to rejoin us here in the next few minutes, and we have it worked this time with Teams, we'll just postpone this one until later on this year, and we'll start again. I know everybody was looking forward to this meeting, probably as much as I was. But if we're having technical issues, it's all good. Give Torsten here a couple of minutes, and then we'll try it again. in the meantime, I'm actually going to share my screen with the original thing until Torsten comes back.
Okay, I'm back. Sorry for that. So I have the web interface now instead, and hopefully this works.
I got faith in you, Torsten. I got faith
Yeah,
in you.
Okay, I'm sharing. 1 second.
There we go. All good.
Yeah. Okay, thanks. That is great. I mean, the web interface is much more stable. Okay, so I will start from scratch again because I don't know where I left. Okay, so what I have done in preparation for the session is to create 2 or 3 big tables. You can see that this is one of the table. We have an identity which is ever increasing. We have a column which is a random value. We have another column which is always 1, and a filler which is just there to allocate a few more pages to the table. You can see that I have a copy of the same table named Big Table 2. And we can see that Big Table 1 and Big Table 2.
I'm sorry, I'm not able to see the screen.
Oh, come on, this is.
No, we can see your screen. You're just sharing your Teams. Can you switch over to the SSMS window?
Yeah, maybe there's a wrong window. Okay, I will give it another try. Entire screen. Okay, maybe that is the one. Okay, cool. I hope it works now.
Good. That looks good.
Horrible, really horrible. So, but anyway, I mean, the 2 tables I mentioned, both of them have 1 million rows, as you can see, and this is these tables which we will use later on because I want to show some problems with regard to parallelism. So let's start with an overview, or first of all, let's try to understand what parallelism is. So parallelism means that SQL Server can execute queries using more than 1 CPU or more than 1 core at the same time to execute the same query. So that is the definition of parallelism. So that means more than 1 worker thread is working to complete the query. So we will see this later on. So we will also see that parallelism will increase the overhead, which is associated with the execution of the query, which is sometimes beneficial. I mean, not the overhead, but parallelism sometimes is beneficial when SQL Server have to deal with, I would say, with reporting. So when you have an OLAP environment where you have to deal with millions of rows and you want to aggregate, so normally you have a column store index on top of your table. So in this case, parallelism definitely makes sense because we will see that column store indexes definitely benefit from parallelism because of the batch mode and the way the algorithm works. Yeah. So, but when you have an OLTP system, then parallelism is something you want to avoid because again, it has an overhead, and we will see the overhead, and we will see that parallelism has an impact on the performance, especially when you run an OLTP system. Your query, the execution of the query will take longer. The more CPU, the more cores you add to the query. I mean, it's not you adding more cores to the query, it's SQL Server, but you allow to add more CPUs and more cores. Yeah, that is something we really have to consider. So hopefully you know that there is a limitation in terms of the available maximum SQL Server or the internals, this DMOS, this info view. There is 1 column which gives you an idea about the maximum worker threads. So on my machine, depending on the CPU, I have 576 worker threads available. So that means only 576 worker threads can be allocated at the same time to execute your workload. If the number of maximum worker threads is allocated, then the query has to wait in front of a queue. That one is called a thread pool starvation. So we will see this later on. That is very easy to detect, but very hard to handle. I mean, there are definitely ways to do it, and we will see some of the solutions. But this will already give you an understanding that parallelism has its own, how can I say, its own challenges. Yeah, and again, it's very hard to find the balance between parallelism and performance, because most people associate parallelism with more performance, and that is not true in any case. So what I also want to mention is that even SQL Server there's a background noise here. So even if SQL Server finds a better plan, so the other way around. When SQL Server optimizes the query, and the query is complex, so and there are several other pre-requirements which has to be fulfilled, but SQL Server, then the engine considers parallelism. So, and there is no guarantee that the parallel plan alternative is a better choice than the serial one. That is also something which we will cover here. So, but at least when the cost threshold for parallelism or the estimated subtree cost for a query is greater than your cost threshold for parallelism, SQL Server considers parallel plan. But again, there is no guarantee that the parallel plan finally is selected, right? So SQL Server, or in order to run a query in parallel with more than one worker thread, there are some criteria which must be met. So you can see that SQL Server must be running on a multi-processor, multi-core, or hyper-threaded machine. I mean, this is the case. I have never ever seen a one-core, one CPU machine. Yeah, in these times, it's always the case, I would say. So the processor affinity configuration must allow SQL Server to use at least 2 processors or 2 cores. Yeah? That is something which we will see. That is very, very important when you have a VM on-premise SQL Server. I've seen some instances where people set the affinity configuration, so the affinity mask, and in the end, they end up with a lot of performance issues. Yeah, so I will show you how to handle this in a correct way, because this is definitely a good way to limit the number of CPUs which can be used by SQL Server. But again, there is a specific trace flag which you need to enable to avoid performance bottlenecks by the CPU. So the maximum degree of parallelism, this is for sure an advanced configuration, must be set to 0, which means this is a default, and 0 means SQL Server can allocate as much as available CPUs or cores, yeah, or it has to be set to more than 1. So you can, and this is something which we will see, you can set your degree of parallelism to, I don't know, maybe 4, because you don't want to use more than the maximum of 4 threads for a query. By the way, this is not true. This is a multiplication or multiple of n. That means even you have your maximum degree of parallelism set to 4, SQL Server still can allocate n times 4 cores for a query. So we will see this. This is dependent on the so-called branches. So when you have, for example, a merge join, which is a streaming aggregate or streaming operator, so we have at least 2 branches running at the same time. It means when you run a query with a merge join in parallel, and you have you set your degree of your maximum degree of parallelism to, I don't know, 4, then SQL Server internally allocates 2 times 4 cores, which is 8. So that is something people need to understand, because that is sometimes the reason of thread pool starvation. So this is the shape of the execution plan, right? This has definitely an impact on the maximum number of cores which are allocated by a query. So then we have, a maximum degree. We have MAXDOP setting on the resource governor, and for sure also on the database. Yeah, so the instance level will be overruled by the database setting, and this is overruled by the resource governor. Resource governor is, if I remember correctly, an enterprise feature. very, very helpful in order to balance or to prioritize a specific workload depending on a specific function. I have an example here, but I guess 1 hour is too less in order to show how the resource governor will work. But just want to make you aware that the resource governor have a resource pool, and here you can determine the number of the number of cores which can be allocated by a query, depending on your workload. So, and the estimated cost to run a serial plan for a query is higher than the value which is set in the cost threshold for parallelism. That is something which we will cover. So we will start very easy. And you can see that this view I already mentioned. So this DMO is this info. So when you run this query, one second. When you run this query, this is my machine. There are a lot of more very, very helpful and useful information in this view, but just want to concentrate on these 3 columns. And you can see even the last column is calculated. You can see my SQL Server is running on a laptop, which is in front of me. I have 1 CPU. This is a physical CPU. And this CPU has 8 cores. So it is hyper-threaded. And that is the reason why I have only 1 physical CPU, but 8 cores. So that is, whenever you start with a performance tuning, even SQL database, you need to understand how many cores, how many CPUs are available. That is a very, very important information, right? Because otherwise you don't understand how to tune your workload and which limits you have. So the maximum degree of parallelism, as already mentioned, must be set to either 0 or more than 1. So you can configure the cost threshold for parallelism by either SP-configure. You can do it in the instance setting. You can do it on the database setting. You can do it on the resource governor setting, and so forth. So when you run a query when you run this query, you will override the default. Or sorry, I'm not overwriting the default. I'm overwriting my default, which is not 5. By the way, we had a conversation with Microsoft and asked Microsoft, why do we have still the number 5 as a cost threshold for parallelism, which is still the default? The default, if I remember correctly, this was a default which was set before, I didn't remember, in the 19s or whatever, in 90s. So in former times, 5 is when a query, or is it a SQL Server expected that a query runs longer than 5 seconds, then SQL Server considers parallelism. But we all know that the CPUs are much, much, much faster these days. So therefore, 5 is definitely not, I would say, meaningful value anymore. So we asked Microsoft why we are not changing the value, and the answer is very simple. 5, or even if we change it to 50, even if we change it to 100, it is always wrong, because the cost threshold for parallelism, which you have to set, is depending on your workload. You have to figure out the right cost threshold for parallelism, again, depending on your workload, which can be changed over time. So that means even if you set a cost threshold for parallelism maybe to 50 because you think it is more meaningful for an OLTP system, maybe this is a better choice than 5. But over time, you will realize that even 50 is wrong. Maybe you will have to increase it or you have to decrease it. It depends on your workload. So in that, there are a lot of articles available with recommendations about cost threshold for parallelism, how to find the right cost threshold for parallelism for your SQL Server. To be very honest with you, I've never ever read an article which give me the right, let's say, instructions, or even at least the right hints to find the best setting for the cost threshold for parallelism. It is really hard. We will see this over time. That there are ways in order to find a better setting for cost threshold for parallelism, but I'm pretty sure you will not find the optimum. So, okay. So again, so we can ask SQL Server about the maximum degree of parallelism on an instance setting, and this is also available here by when you open the properties and we go to advanced. So cost threshold for parallelism on the instance level is set to 5. The resource governor can override this one. And if I remember correctly, even on a database level, it is now possible to change this somewhere. Yeah, maximum degree of parallelism. So that means the instance level is a default. When you override the level on the resource governor or even on the database, this will be overruled. So the hierarchy is instance, database, resource governor. So depending on your choice. So when I execute a query like this, and by the way, I'm Kevin, can you? I cannot see a red, but I'm still sharing, right?
Yes, you are.
Okay, that's great. Okay, I'm a little bit confused because normally I have a red frame, but I cannot. If it is working, I'm fine. Okay, I don't want to ask anymore why it is not working. So anyway, so when I execute a query like this, and by the way, what I did in order to do not wait for the result. So there is one option here in the query options to discard the results after execution. So because what happens when you ask SQL Server to return values from a big table or even from a table, the grid, which is, let's say really, which is painted, yeah, which is, SQL Server have to how can I say, to constrict, to create a grid, then it has to visualize all the data. This has its own overhead. So when you really want to have an impression about the performance of the query and you want to measure the time, my recommendation is to discard the results after execution to avoid that you have this overhead, which is sometimes, or which is not really predictable. Yeah, that is the reason why I discard results when I do performance tuning. And what we will do here is I will definitely include the actual execution plan. So, and we can see that because of my current maximum degree of parallelism setting, which is set to, let me go back to 0, SQL Server can now allocate as much as available CPUs. So when we can see the information about the allocated CPUs or cores in our thread statistics. So we can see there's one branch. We will talk about branches later on. And we can see that there are currently 8 used threads. That means this query is running with 8 concurrent threads running in parallel. And the reason, again, is not just because of maximum degree of parallelism. There's another setting which we will see in a minute, which is cost threshold for parallelism. So we can see that on the select operator, the estimated subtree cost here in the middle, I cannot move the mouse because otherwise the pop-up window will disappear, but the estimated subtree cost is calculated or estimated with 24. There is no unit because this is a combination of IO, memory, and CPU. So, but 24 is definitely greater than the default, which is 5. I already mentioned that. So, and that is the reason why SQL Server now considers parallelism. And it seems that SQL Server selected the the parallel plan and prefer this over the serial plan because the serial plan as an alternative is more expensive than 24. So, but you have to understand that the estimated subtree cost is an estimation based on statistics. Statistics is, when you create an index, or you allow SQL Server to create statistics whenever you use a specific column, which is not an index column in a predicate, SQL Server will create a statistic for you and gives the engine an estimation about the numbers which will be returned by this query. So we can see all the information when we go to the table scan, or to the clustered index scan. In this case, it is not a heap. Instead, it is a clustered table. So we can either have a heap or a clustered table. But the index is not really useful because it is a scan. For sure, what we are doing is select all from big table, group by, option, recompile. I mean, there is no reason to have a clustered index seek. Yeah? So normally you prefer to have a seek when you have an index. Yeah? But here we can see that the estimated number of rows is estimated as 1 million, which is the precise value. But I already mentioned that the estimated subtree cost is depending on these statistics. That means when your statistics are stale because you forgot to create a statistic maintenance job even in Azure SQL database, most people think that they do not need to worry about index and statistic maintenance in SQL database anymore, which is completely nonsense. Yeah, so you still have to set up your jobs, I don't know, with a runbook or elastic pool or whatever. So you still have to maintain your statistics, because when your statistic is stale, the estimation is wrong. When your estimation is wrong, it can be either a value which is higher than the value which will be calculated when the statistic is refreshed, or it can be lower. And depending on that, SQL Server will either select a parallel plan, which is a better option, or it will select a serial plan, which is maybe not the best option. And the reason is that your statistics are stale. So the value of 24, as already mentioned, is calculated on statistics. So let me do the change, and I will set the maximum degree of parallelism from 0, which is the default, and I will set it to 1. When I execute the same query another time, and we will, let me load up a bit so we can see what happens. This time, it is not a parallel plan anymore, and we can see the cost. The cost is, by the way, 118. And now we can see that 118 is definitely much greater than 24. That was the reason why the parallel plan was preferred. Yeah? But here, we don't allow SQL Server to use more than one thread. And we can see the reason that SQL Server is not, in this case, not able to run a parallel plan. The reason is non-parallel plan reason. So this is a property. This is set to maximum degree of parallelism is set to 1. So someone, you know that I did it, someone sets the maximum degree of parallelism to 1. So therefore SQL Server cannot run a query in parallel anymore. That is definitely something which is very useful when you have your resource governor in place, right? Because then you can prioritize specific workload and can allow a workload to run in parallel, whereas other, let's say, other connections using another resource pool, they only can run queries, I don't know, in a serial fashion, or maybe with 2 cores or whatever. So that is definitely something you can consider. At least you can see in the properties of the execution plan the reason why the query is not running in parallel. So you can overwrite, even if you set it on an instance level, the maximum degree of parallelism on a query level. And you can say recompile is just to make sure that a new plan is selected. And we can say maximum degree of parallelism is set to 0. That means on a query level, I can overwrite the setting which is set on an instance level. So by the way, this is the way SAP is doing it. I had one customer which is running SAP on SQL Server, and SAP is doing exactly this. Whenever they execute their internal queries, they run all the queries with all available cores. When you run a user query, it is set to 1. Which is great. I mean, SAP is always fast as far as you do not execute a user-specific query on SQL Server. That is really nice. Okay, so let me skip this one. These are just different examples on database level, resource governor, and so forth. This is nothing we we should execute. Let me do some housekeeping. So just to make sure that all the examples I will share with you are still working. So the next property we need to understand is the cost threshold for parallelism. And I already mentioned that several times. So the query has an estimated subtree cost. You remember the parallel query which we executed has a cost threshold or a subtree cost, estimated subtree cost of 24. The serial one has 114. And now it is on you to decide where you want to set the break even. So that means all the queries below your cost threshold for parallelism will very likely run in a serial way. Most of the queries which are more expensive than your cost threshold for parallelism will be likely run in parallel. That is the idea of cost threshold for parallelism. The cost threshold for parallelism is set to 5, right? As you can see. And again, if I run this query here, we can see that because I set it to maximum degree of parallelism to 1, it is set. The estimated subtree cost is evaluated as 29. So this is a serial plan, and this is definitely higher than 5. When I execute the same query now without the limitation, so that means SQL Server can allocate more than just one core at the same time. So degree of parallelism, it is not running. 1 second. Maybe there's still something I need to reset. 1 second. Sorry, my mistake. 5, not 50. So now it should run. Yeah, now it should run. This time, again, SQL Server selected the parallel plan because it is a little bit cheaper. But this is just depending on your estimated subtree cost. This has nothing to do with the time it takes to execute the query. Again, the unit is a combination of I/O memory and CPU. There is no time which is included in the estimated subtree cost. I mean, yeah, CPU is some kind of time, yeah, but this is not a guarantee that a parallel plan will execute faster than the serial plan. It will only tells you that this is a cheaper plan with regards to the resources which are allocated to the query. That's all. Right. So let me go back. Again, when I set the cost threshold for parallelism now to something else, you can already imagine when I set it to 50 and by chance I did it wrong, then the query is still running in a serial way because 24 is not greater than 50. So and again, the cost threshold for parallelism is, this is also true for the maximum degree of parallelism, but the cost threshold for parallelism is set on a database instance level. There is no setting on a database. There is no setting on a query. And that makes it so complicated to find the best cost threshold for parallelism for your entire workload. It's almost impossible, right? So there is an overhead. And I hope it works. Sometimes it doesn't work, but even if it doesn't work, I'm pretty sure you will understand the overhead. What you can do is the following. I can, for sure, first of all, flush the procedure cache, just to make sure that there's nothing in our procedure cache, so that SQL Server really will recompile the plan. And what we can do is, I can execute this query, which is a little bit more complicated, right? And when I execute this one, I will do it here. And we will, let me do this, set statistics, statistics IO on and time on, why not? Oops, time on. So now I will execute this query now. So we can see that there is, I don't even need the execution plan, but the execution plan is currently a serial plan. So this is considered, or this is finally a serial plan. There is no parallel execution at all. But there are some trace flags. So there's a trace flag, which is 8 675, you can see the maximum degree of parallelism is set by intention to 1. So this is guarantee that the query is running in a serial way. And we can see how long it will take in order to optimize the query. So the query engine itself has so-called optimization phases, starting with 0 and end by 2. Here it is end by 2. You can see them here. Search phase 0, which is the first search phase, but it is 0 based. Then we have search phase 1 and we have a search phase 2. You can see that there are internal cost thresholds. That means if your query is still too expensive after the first evaluation and first optimization of your query, then SQL Server considers a second optimization phase, which is called search phase 1. And SQL Server will now add more algorithms and more rules. They call it rules, more rules in order to simplify the query, in order to reduce the estimated subtree cost. Right? You can see in the search phase 0, the cost was 24. That was the best plan found in a specific time, because there's also time factor to consider, because SQL Server don't want to, or you don't want to wait, I don't know, a minute to find the best plan, right? But finally, the query execution only takes a second. That doesn't make sense. So that means there is always a balance between your cost, so the optimization, and the time it takes to find the best plan within a given time for this specific search phase. But you can see that the cost was too high. Therefore, SQL Server entered the second search phase. You can see with all the additional rules in order to simplify the query, we will enter with 9.5. So and you can see that this was still too expensive. So SQL Server now decided to go into the search phase 2, which is the last one within the optimization. But you can see that there was even applying more and more rules in order to simplify the query. The cost, which was finally achieved, is 9.5. It's the same. So it was wasted time, because we are wasting CPU cycles. We are wasting time. So the user have to sit in front of the screen, they have to wait for the optimization, right? So, but anyway, when I now allow SQL Server to run the same query, in parallel, we can see what happens. So this time it runs in parallel. You can see the double arrows here, which indicates a parallelism. So we can see something interesting. So the search phase 1, let me go up. Search phase 1 is or SQL Server is going through the search phase 1 2 times. This wasn't the case before. That is because SQL Server considers parallelism not in the search phase 0, but instead in search phase 1 the very first time. So this is for very simple plans. This is a more complex plans. You can see that because we are executing, or we are executing the second search phase 2 times. For sure, we have an overhead which is allocated to this. Yeah, so that means parallelism from a query optimization perspective, to find the best possible, not the best. Yeah, it is not considered to be the best. It is called good enough plan. Yeah, so to find a good enough plan and compare the serial with a parallel plan, it has an overhead, right? CPU cycles. You are wasting CPU cycles. So, and that is something which you can also find by a query, which I didn't remember anymore where I find the query, to be honest. Not my query, but you can see that, oh, sorry, I'm discarding the results. 1 second, I need to go to another session. Okay, you can see that the compile time, right? The time, the CPU in milliseconds, right? Depending on the complexity of the query. And we can see that parallelism itself have its own overhead to find a parallel plan. It's not for free. Okay, let me go down. So, by the way, Kevin, how much time do I have?
Well, there's about 3 minutes until the top of the hour, but I figure say 5-10 minutes after that.
Yeah. Okay. Then I will skip this one. So yeah, sorry for the problems with Teams I had in the very first beginning. Starvation. Okay, let's go here because I already mentioned several times that there is a problem on negative side with regards to parallelism. So it is called thread pool starvation. So thread pool starvation occurs when there are no more free worker threads available. So let's do the following. Select all from this DMOS, this info. We can see that on my machine, as already mentioned, I have, my maximum worker thread is set by intention to 128 because I want to show you a thread pool starvation. That is the reason why I decrease the number of available worker threads. But even if I have 576, this is, by the way, again, depending on your CPUs, because the more CPUs you add, the more you have to pay, the more expensive your license will be. But for sure, the more CPUs can be used in parallel, yeah, for your concurrent workload. You have to pay for it. It makes no sense to override the maximum worker thread only when you want to demo something like thread pool starvation. So anyway, there is a limit. That means in my case, I have only 128 worker threads available for the entire workload. So now we need to ask ourselves, what will be happen when the maximum worker thread is exhausted? That means that a query cannot run because there is no worker thread available. If you remember, or hopefully you know that there's a life cycle of a query. It always starts with a suspended queue. That means your query, all the operators, which you can see in the execution plan, they have to wait for the required resources. So like the disk, maybe memory, CPU, maybe a lock, maybe, I don't know, something which is going on. There are more than 1,000 reasons that a query has to wait. You will see all the reasons within DMO's wait stats, right? So this is the most important query whenever it comes to performance tuning. So we have more than 1,000 different reasons that a query has to wait for a resource, right? So once the resource becomes available, the thread which have to handle the work, the thread is doing the actual work, will move from the suspended queue to the so-called runnable queue. A runnable queue is a sorted queue, whereas the suspended queue is an unsorted queue. Yeah, the only way in order to prioritize threads within the queue is a resource governor, by the way. Yeah, but anyway, when it comes to the runnable queue, the sorted order, the CPU will signal a thread, and this thread can run or can use the CPU for 4 milliseconds, which is so-called quantum. After 4 milliseconds, SQL Server or the engine, it has its own operational system because it is a non-preemptive one, will force the thread to leave the CPU and will take the next thread. But you can see already when there is only a limited number of worker threads available for the entire workload, when there is a query which needs an additional worker thread which isn't available, so there is no idle worker thread anymore, the query itself has to wait. That is called thread pool starvation. Now you need to think what happens when we run more and more queries in parallel. And all the queries are running in parallel. That means we have a concurrent workload with a lot of parallel query executions because maybe the query is too expensive. That means let's consider we have a query which have, I don't know, 8 cores, which will allocate 8 cores. That means we can only run 128 times divided by 8. That is the maximum number of queries we can run in parallel. Otherwise, all other queries will be queued and they have to wait. That is called thread pool starvation. We have a wait stat, which is called thread pool. I will demo this one. So okay, I already set it to 128. You can see this one. And the cost threshold for parallelism is set to 5 now for demonstration. Really doesn't matter because you will always reach the limit. And the cost threshold for parallelism is set to 5. Perfect. And now if I execute a query like this, we can see what happens. This is a serial plan. Yeah. So for sure, because we force the query to run with just one thread. What I now will do is I will reset the weight statistics and execute. I execute. It's not a simulation. It's really executing this query. You can see the query here by ostress, which is part of ARML utilities, and I think they call it now database experience tool. I didn't remember anymore. Just Google for ostress. Without ostress, you cannot do performance tuning because you always have to consider parallel executions. And you have to create your own workload. So what we will do here is we will run the same query on 80 times, also 80 times at the same point in time, so that means we will start 80 executions at the same point in time, 2 times in a quiet mode. So, and let me execute this one. This will give us an overview about the CPU allocation and a lot of more. So I will also execute this one in another session. So, and it will take a moment. Shit. Sorry, I need to go here. Yes. So we can see that currently the workload is running. So yeah, that's perfectly fine. So, and there is one DMV which is called DMOS schedulers. OS is operational system. So what we see here is the number of threads which are waiting in the queue because there is only limited number of worker threads available. There is none because 80 times one thread is 80. 80 is less than 121, which is currently the number of maximum worker thread, which I set by intention. That means I don't have any bottleneck. It is executed in 47 seconds. And we can see that all the queries, it is just a snapshot, but you can see 84 rows, which is our workload. All of them are running, for sure suspended. You remember the life cycle of a query, but none of the query is waiting for your CPU. This is something which we can see also from a wait stat statistic. We can see that the thread pool, there's a little bit of thread pool, but believe me, this is caused by another query which I run. So this is neglectable. Yeah, there's no thread pool. There is no CXPacket. CXPacket is a time a query is executed in parallel. It just stops the time when the query goes into parallelism, and it will stop the time until all threads within your parallel execution have done their work. So I have read a lot of articles about CXPacket is bad, blah, blah, blah. I don't know. No, this is not the case. CXPacket is just an indication that you're running queries in parallel. And now you need to think about what is the reason why a query is running in parallel. Because the estimated subtree cost is higher than your cost threshold for parallelism. So what can I do in order to avoid CXPacket? I can tune the query by maybe setting the right index in order to reduce the estimated subtree cost. And then it is very likely that the query will be run in a serial way and not in a parallel way anymore. So let me show you the example with the thread pool starvation. This time we can see, sorry, I forgot to, I can even do this. So we can see this is a query which runs in parallel, and we already know that it will take 8 times, so 8 cores to execute the query. And when I execute the same query now in ostress, I will reset the statistics. Same workload as before, but this time I don't limit the query to be executed in parallel, in a serial way. We can see something interesting. I hope it works. I'm pretty sure it works, but maybe I'm not fast enough. Then I need to execute the query another time. We can see that Yeah, perfect. That's, yeah, we can see that there is a queue. These are the queues. This is a number of threads waiting for an idle. And for no, this is to be very precise. This is a number of tasks waiting for an idle worker thread. Yeah, that means the query is waiting for CPU, and you can see that there's even an error message. Yeah, you can see here target server is running blah blah blah, and you can see this is because of not available idle worker threads. We can see that if I ask now for the DMO's wait stats another time, this time we can see a high number of thread pool in combination with CXPacket. So the reason why we are running into thread pool is CXPacket. But I mean, CXPacket is just there because the query is too expensive to run. So what we can do is, for sure, we can create a clustered index, for example, a non-clustered index, for example. Right. If I execute the same query another time, I still have it here, I guess. Oops, 1 second. I have it in my clipboard somewhere. This is one. We can see that this time, because I have an index scan which fully supports the order by, because you can see the ordered property here in the end or in the middle of the pop-up window. So that means the order, the sort operator is gone. The sort operator is very CPU intensive, so therefore the cost, the estimated cost is higher than 5. This time we have a supportive index. It means we can run the same query another time. I don't want to execute the query another time, but you can believe me that this time only 80 threads are allocated instead of 80 times 8 threads. That was the reason why we run in thread pool starvation. And that is one way to tune it. Just need one additional minute, Kevin, because what I want to show is, this was an example which, you remember the query which we executed over time, or several times in my demonstration. And we can see what happens. When I execute the query in a serial way, you can see the DOP, which is degree of parallelism. 1 means a serial execution. And this is the CPU time, elapsed time, and the average time. So that means the more CPUs, and this is an OLTP query. This is not a column store, a big query on a big table where we aggregate data and we can benefit from batch mode. This is an OLTP query, a simple OLTP query. We can see that the more DOP we add, the more cores we add, and we allow SQL Server to use to execute the query in parallel, the longer it takes. The reason is we are waiting for CXPacket. CXPacket have its own overhead because finally all the threads running in parallel, they have to be, there is an overhead, they have to be coordinated by the so-called thread 0, which is the coordinator thread. And there is a gather stream operator, which we always see in a parallel plan. And once the gather stream operator is, or all the threads reach this operator, then the query will be executed in a serial way. But the parallel plan within the overall plan have its own overhead, which we can see here, caused by CXPacket, or measured by CXPacket to be very precise. And you can see that CXPacket is increasing over time. And you remember that executing a query means it is elapsed time plus CPU time. And the elapsed time is nothing else than CPU time plus wait time. That means if I'm waiting for CXPacket and the coordination because of the parallel plan, the execution itself takes longer and longer the more cores are added and allocated by the query. That's it. I mean, normally this is a session which I will present in 1.5 hours at least. But and sorry again for the technical problems I had in the very first beginning. But I hope at least you have a rough understanding about parallelism, and you understand that parallelism is not always your best friend. Yeah, so you really have to think about which queries are worth to run in parallel and which queries should be tuned in order to avoid that your cost is too high, and therefore running in parallel. Any question?
I think the only question that I've seen, no, I actually got two. Would you please advise why MAXDOP is mostly set as 1 for SharePoint?
Yeah, SharePoint. I mean, SharePoint is really a funny application. You remember that Microsoft introduced sparse columns. Yeah, sparse columns. You remember that? I mean, sparse columns give you the opportunity to have a table with more than 30,000 columns. A table with more than 30,000 columns, whereas most of the columns are null. The problem was because of the ER model of the SharePoint database, which is in the background SQL Server. So SharePoint is the reason that it is set to 1 is otherwise most, and I would say all the queries will run in parallel. And I think Microsoft decided to set the MAXDOP DOP setting to 1 in order to avoid thread pool starvation and all the other negative effects which we have hopefully seen in this session. That is the way in order to make sure that the performance is not getting worse. I mean, SharePoint is already slow, I would say.
All right, and final question here. Can you confirm the Express edition does not allow parallelism?
The Express, so to be honest, I never ever worked with the Express edition. I work with standard. Standard for sure works with or can run queries in parallel as for sure enterprise. I have no idea about the Express edition, but I'm pretty sure it's documented somewhere.
Oh, absolutely. It's Microsoft. They're going to document the heck out of it. All good.
Yeah.
All right, so that seems to be the final question here. So with that, I'd like to remind everyone that in 2 weeks on June 20th is what is Azure Arc Enabled Data Services with Nikita Tukaru. And that one's going to be, like I said, on June 20th. And then the following week, June 27th, is Hybrid Disaster Recovery with SQL Server 2022 with Armando Lacerda. So with that, I do want to thank Torsten for working through the technical issues we had.
Yeah.
That was fun, as always. So all good there. If you have any more questions, please be sure to drop them in the chat. We'll all be hanging out here for a few minutes.
Mm-hmm.
And then hopefully everyone has a great day. And as always, this session will actually be on YouTube here in the next few days. So be sure to join us there. And as always, look out for our next session coming to you soon.